Hey everyone, today we'll be doing another Leetcode 111 minimum depth of the binary tree easy problem. This is we have already done the maximum depth of the binary tree. This is much easier than that. That was a bit complicated. But in this problem, given a binary tree, find its minimum depth. The minimum depth is the number of nodes along the shortest path from the node down to the its nearest leaf path. So in this condition, and the leaf node is a lone node where there is no right or left, no children, you can say. In this condition, example number one, we have 3 and 9. This will be our, you can say, closest path, and the distance will be 2. That if what was it, depth, the depth will be 2 because the root node will be considering as 1, and at each level we will just add 1. We have done the uh, maximum depth of the binary tree or something like that. You can see that also if you want to, but in this we will just consider the base case. Yeah, if the base case is no, if there is no root to begin with, we will just return 0 because there is no root, there is no height. And then we will check to the left and check to the right. So on we have another case in which there is no left or right. For example, we in the case of 9 we will just return 1 because this is our leaf node. And on the other case, in the case in which we do have our left and do have our right, we will just take the minimum of these two. Like in this case, you can see it that we will be taking the minimum path, so we will just use the minimum. And also, what if we have a root on the left but not on the right? So you can see if this 9 has another children 10, or if this 15 was not there, we will just be adding 1 because we do not care if it is, or if there is any left node or right node simultaneously. Like one parent have a left node and the right node. If there is one, we will just add 1 because it means that it does have uh, its own level, and in its own level, and its level should be incremented by 1 when we are considering the whole left or the whole right. I hope this makes sense. um, for example, I will try to give another example. Like if there was no 7 and 15 here, or if there was a 15 here but not the 7, the depth is 3 regardless if there is 7 or not. And same goes for the 5, the depth is still 3 uh, regardless if there is 15. And same with 9, if we do not care if there is 9 in or not, the depth will be 3. So that's it. Now we will check our base condition. If there is no root to begin with, we will just return 0. And if there is no root left and not root right, they both are null, we have our leaf node. So to leaf node, we will just return 5. And what if we have our root, not root on the left, but we have our, we will check for the left first. So if there is, we have, and a right, RIGST, there is no right root. For to give an example, we will be starting our base condition. So what if we do not have something on the left but we do have something on the right? So we will left, we will go to the left. So, and root left is still there, we will just call recursively by adding 1 and calling the function itself again by, and now this time passing it minimum depth, passing it the root left because we only have our root left. And the root left is not there. And if there is root right, the same, the opposite case. If there is no left but there is right, if there is no right but there is left, I explained it earlier how we'll be incrementing them. And because we do not care if there is a left but there is a right, we will just increment it and pass it to the function again. Self dot minimum dbth. So now root we'll passing it root and right. After that we have our most common condition, base, not the base condition, but what if we have a root to the left and root to the right. We will just add one because the one will be our root condition, because obviously if there is no root we will return 0, but if it does not execute then obviously we have a root. We will just increment it and uh, self, we will call the function again, passing it our root to the left, and after that we will pass it our root to the right, and this is it. So we will be taking the minimum because for example we have passed the root, we have 9 and 29 has 1 to its depth and this whole tree has 2 to its whole depth. So we will be taking 9 and adding 1, so it will give us 1, uh, just give us 2. For example in the base case, in our given example we have one here, and the left, on the left you can see there is 9, so we will be returning 9, and on the right we have two, another subtree you can say. So we'll take minimum and add it to the 1, and so we'll be getting 2. 2 will be the minimum path as you can see, and that's it. That was our whole code. Now let's see if there are any errors. There are no errors, and that's it.